SSG circuit. So let me just go back and show you that still if I pop this, the high voltage is coming through even at 9 volts, and you can see it popping up there on the scope. At least I hope you can. So I'm going to hook the battery up and we'll take a look at it from there. I have this 12 volt battery, and you see it's plugged into the output of the SSG circuit. And over here I have the clips for the voltmeter on the battery. It's a 12.5516. So let's start this thing up and see if this 8 volts or 9 volts can actually charge this battery. So there you see the battery going up. Alright. Of course, this circuit here is not tuned. There's a spot, what they call a sweet spot in these circuits, where you can get an adjustment that's really gets the charge to accelerate. So anyhow, you can see it's not killer, but it's charging. But it's a big battery for this little circuit. I've used this to charge alkaline batteries, 9 volts and little ones, and other small lead acid batteries. I'm not really into this because I don't have a big use for lead acid batteries. I'm a fan of LiPo technology. But anyhow, let's see what's really charging that. I'm going to go back to the scope again. I'll unplug this and hook the scope up. I'm still at 9 volts powering the SSG circuit, and I'm hooked back up to the scope again. So I'm going to start this up. And you can see the neon light is glowing solid here, and the scope trace is going high. I'm probably going to sacrifice this transistor for the sake of this experiment, but it'll be worth it. So anyhow, you can see the trace is actually completely off the screen, so that would have to be over 400 volts right now. And yeah, sure, everybody knows that there's no power behind this, there's no current, and it's not meant to have current. It's just meant to have this high voltage, and it's good for charging lead acid batteries. It'll recondition them and charge them, change the chemistry a little bit so they charge fast. And this can all be done without saying a word about over unity, or free energy, or radiant energy. It's just something that works. People are using it, and they're having a lot of fun with it. So let's go on to another part of the experiment. Alright, now we're going to get into some of this really highly technical stuff. This is going to be about the 555 timer circuit, which has been around since the caveman days of solid-state electronics. So this is a little 555 chip here, and it's in a circuit that's known as a motor control circuit, or a PWM circuit, pulse width modulation. And what happens here is if you're controlling a motor, you can change the speed by changing the pulse width. So if you're looking at the scope here, if I turn the pot, you can see the square wave on the top getting bigger or smaller. And when it gets bigger, it's turning your motor on for a longer time, or your light bulb or whatever, and it controls the speed or the potential that way, as opposed to changing the voltage, which has a different effect on your motor. It certainly doesn't run as strong. So if you look at what I'm doing here, if I turn this down, I have this little light bulb here, which is dim, and if I turn it up as the pulse width changes, the bulb gets brighter. But there is a pulse, and you can change the rate of the pulse by changing capacitors and stuff like that. So what we're going to do is, rather than spinning this stator motor here, which created a pulse that was running this originally, I'm going to put the pulse from the solid state into this circuit, just to show you that this circuit is meant to run on a pulse. It won't run on anything else. So let me get that hooked up and we'll take a look. Here's what I've done. I've taken the output from this PWM or timer circuit. I've actually added a little MOSFET or FET transistor here, which bolsters the signal up a little bit. And I'm putting it into the SSG circuit where the trigger from this oscillator was originally. I still have the coil part of the motor oscillator generator plugged into where it should be in the SSG circuit. I have the power supply off, which I'm going to turn on now. Hey, what ho! You can see that this does the same thing that the oscillator did. So right now I want to call this an oscillator. There's no trigger in there now, so it won't run. It'll probably just do that and stop, because the stator legs are energizing on and off, and there's some magnetism and eddy currents and stuff going on there. Different thing to talk about, but anyhow, so the scope is hooked up to the square wave circuit right now, and you can see that changing the pulse width has some different effects on how the circuit works. And if you think this won't charge, it'll charge. This is probably what I find to be one of the best ways to charge. Maybe I can hook that up for a second. We'll take a look. I've hooked the battery back up to the output of the SSG, and I have the meter hooked up to the battery again, and we're at 12.5632, whatever. And I'll turn on the power supply, which is still set at 9 volts. Yeah, sure. Just what I expected. And once again, so you're charging a 12-volt battery with 9.3 volts. And of course that'll continue to go up. So much for that. Now you can see that the Bedini circuit works from pulses, and it's capable of charging larger size batteries with less input than the battery itself. And I'm not saying that there's more coming out than going in. It's just simple pulse circuitry, and there's nothing unusual about that at all as far as I'm concerned. It's just something that works. Let's move on. Before we go on to more boring stuff, let's take a look at another oscillator of a kind. I mean, this is something that probably the younger guys haven't seen before, but I have a few of these. This is an old Ford ignition coil, and on the end of it is a mechanical oscillator. So what happens is this oscillator vibrates back and forth as the core moves a little reed and set of contacts, so on and off, and of course when it oscillates, that goes across another coil in there that has an awful lot of turns, and you get some high voltage. So let's take a look at that. So here you can see the oscillator running. Cool, huh? And on the top here are the high voltage Sherman Olson.